We're now moving into rational inequalities. So this first video is going to look at how to solve a rational inequality by just investigating the graph. So I have the equation here, or the inequality, x minus 1 over x squared minus 4, and I want to know, where is that function greater than 0? Here is the graph representing this rational function here. And just like when I talked about polynomial functions, I'm interested in the rational functions graph where we are above the x-axis, right? Because that means we are greater than 0, so above the x-axis. We're going to come down here and we're going to look at that. So this section over here, none of that is above the x-axis. In here, I am above the x-axis. Let me get my highlighter out. I'm above the x-axis between, what would that be, -2 and 1. And then I drop below. And then right here I pick up again at +2 all the way to infinity, it looks like. Now, because my symbol, my inequality symbol, allows me to be equal to the x-axis, I can go ahead and I can include my x-intercept. Now, the thing about a rational inequality, though, is I can never actually get to -2 on the x-axis because it's an asymptote. So when I have asymptotes, I have to use parentheses, because remember, I never get to -2. So I would be from -2 to +1, and then here we have an asymptote, so we would have a parentheses there all the way to infinity, closing my parentheses. So that solution set looks like -2, 1 with a bracket on 1 and a parentheses on -2, union parentheses for this one, +2 to infinity. So when you're dealing with rational inequalities, asymptotes are always going to have parentheses, but intercepts can have a bracket if the symbol calls for it.